recording. See, there it goes, we're recording. All right, so I'm going to actually skip on to the next one. And we're going to move down. And we're going to convert. These are the simplest kind of conversions, okay, for prefix conversions. And then we'll get to sig figs and all that kind of stuff. Okay? Oh, that square box is supposed to be a micro. So I have 977 micrograms. It's funny because I fixed it in the one I sent out to you guys, but I didn't fix it in the one. This is actually in the drop box for all the faculty. So what I want to do is convert that. So 977, this is the simplest conversion. What's micro? 10 to the minus 6. So I would say 977 times 10 to the minus 6 micrograms, or grams. Then you want to convert that over because, you know, the decimal's after the 7, right? So normally in scientific notation, the decimal is between the first two numbers, regardless of whether it's a 0 or 1, whatever decimal. It's usually between the first two numbers. You don't usually have a 0 on the left. So then I want to move it over 3 places, so I'm going to go like this. And so that's going to be 977 times 10 to the minus 2. Oh, sorry, minus 4. So if you move it up to the left, the exponent increases in value, but it was minus 6 before, so it goes minus 5, minus 4. Okay, 1.79 decimeters. So I'll do that one. Well, I'll start it. 1.79 decimeters. What is deci? That's centi, so 10 to the minus 1. Yeah, 10 to the minus 1. So I would say times 10 to the minus 1. Meters. Sorry, I had to find it again. So I don't want to leave it like that. Normally, if you, my personal rule, if the exponent is between like minus 2 and plus 2, I usually just write it as what's called a floating point notation, a standard format number. That's okay, but I just would say it's probably easier for people to call that, move it to the left, so minus 1 becomes 0. I'm going to go one place to the left. Does that make sense? Like this. So then minus 1 going up by 1 becomes 0. 10 to the 0 is what? Do you know? 1. Anything raised to the 0 power except 0, I think, is 1. One of those math things they teach you, and you're like, okay. So 0.179 meters. Okay? You notice I always put a 0 on the left-hand side of the number like that when I write a decimal, if it's a fractional number. The reason I do that is because what people in nursing always tell me is like, if you don't put that 0 there, that decimal, how barely you can see it, if you don't put that there, then they'll misinterpret what the number is. They'll say, oh, it's 179. So I have to give them 179 micrograms instead of 0.179 micrograms. It's 1,000 times too much. And you kill people by not putting the decimal place in the right place. Right? Oh, just because I prefer to have it, if it's between powers of minus 2 and plus 2, I prefer to have it as standard format. That's my preference. Now, you can leave it like that, and it's fine. In mastering chemistry, we'll say, oh, that's okay. Yeah, because they just interpret the number in the sig figs.
So, in these poems, how do you know, like, how many places to move the decimal over?
Because in scientific format, you always want the decimal there, between the first two numbers. Okay? It's always between that first and second place, yeah. So this is a stupid one. D. Sorry, I hate these ones. 0.83 megaliters. It's like, I don't even know where that number comes from, but okay, let's say you get that. All right, what's mega? 10 to the 6th, it's a million, right? So you would write this as 0.83 times 10 to the 6 liters. And then you got to move it over 6 places if you want to. You can move it 1 place to the right or 6 places to the right. I'm just using 1 place to the right. Because I want the number to show up, or the decimal to show up right there. Okay? So then what I'll do is I'll shift this over like this. So I'm going to the right now. So when you go to the right, the exponent goes down. Okay? So this becomes 8.3 times 10 to the 6. Sorry, 8.3 times 10 to the 5th. Sorry, yeah.
Does it matter if you go to the right or the left?
Yeah, I mean, what do you mean by does it matter?
Like, because you went to the left on this one, and you went to the right on this one. Is it because it's 0.0? I mean, yeah.
Yeah, because it's 0.0, and you don't want the first number. Sorry, you don't want that first number to be 0. You want the first number to be a number other than 0. I think I said it wrong earlier. Or I think I generalized a little bit too much. Okay, so now we do sig figs.
Real quick,
Yeah.
how come on that one you moved it to the left then, and all the other ones are to the right? Like, wasn't the decimal place already in a spot where you wanted it?
Oh yeah, but yeah, see, that's what I'm saying. This is just preference. You can leave it like this. I prefer when you only have power is like -1 or -2. I prefer you just write it as a number.
Okay.
But this, either one's totally acceptable.
Okay.
Yeah.
Makes more sense. Thank you.
Isn't it a lot easier asking questions when the class is smaller like this?
Yeah.
I'm in your wife's class, so
Out of here.
I was wondering, if, she would like the same preference, or how would she?
But it was one of the exponents.
She
I did ask if she was gonna come
probably,
this
she
week.
probably doesn't care.
Okay.
And I don't really care. I'm just saying what I prefer to see.
Yeah.
Yeah. When I say I don't care, it means I'm not gonna mark you off for points.
Well,
Right?
it says like these exponents.
I'm gonna open this door up because it's hot. If it gets too hot,
I have a question.
if it gets too hot, we will move to a lab, and then we'll open up all the doors. There's actually cool air in here, so hopefully some of that.
I have a question real quick on
Yeah.
8. Where did you put the decimal?
Hey.
977.
Oh, sorry. Yeah, right. This is why when you lose a decimal point, you kill people. I put
Are you
it.
still recording this, dude?
Yeah.
Oh, okay.
Is that -2 or -4.8?
Never -4.
4.
Yeah. Okay. Good. Sig figs. Let's see. What's the best way to do this?
Where can you see all the rules again? You get them in the notes? We wrote them in the notes? Because there's like...
Oh yeah, and the sig figs, you can find them in the book or the notes or Mastering Chemistry if you go online, or if you just type in significant figures on YouTube, you'll find lots of really good videos on this stuff. It seems like every chemistry teacher thinks they have a better video. I know mine aren't any better. I'm just trying to put my notes online, so this is, yeah. All right, so how many sig figs in these numbers? Thank you. Thought, what the heck is he doing over there? All right, so rules. Let's write down the rules. I'll write them on the board. Okay. I'll write the more traditional way of writing them. So the first rule is all non-zero digits. And you can just write on the worksheets. By the way, if you just came in, I have worksheets of all these. Okay. Feel free to come up and grab one. And then we're going to do Sig Figs. We'll do Sig Figs calculations. I'll start you on problems, and you'll do the Sig Figs and the calculations, and then we'll do nomenclature after that. Okay? So, all non-zero digits are significant. And then these are rules for zeros. That's all that it is. The rest of it's all about what do you do with the zero. If it's leading, it's not significant. If it's trapped, it is significant. And if it's trailing, depends on whether or not there's a decimal. If there's a decimal, it is significant. And if there is not a decimal, it's not significant. So like in class, I gave the rules differently because I'm trying to teach like why they're that way. This is just the rules, okay? So, if you look at 8008, somebody in lecture this week actually pointed out something very good. Whole numbers are horrible because you don't know if it's a whole number. Whole numbers we call exact, okay, or whether or not it's actually a measured value. And significant figures have to do with measured value. So if you see a whole number, unless there's a unit that tells you otherwise, you're going to assume, all right, it's measured. So I'll explain that in a second. So let's say this is a measured value, okay? Because it's meters. How do you get a meter? You measure it usually. Sometimes in like a plan, like a drawing, it's exact because in a drawing they're saying this is supposed to be exactly 8 meters. All right. So it's kind of crazy, but let's assume that this is a number that you can count sig figs on. So I have an 8. Okay. So I'm going to mark the non-zero digits. I have an 8 and an 8, right? And then the 0, 0 in the middle is trapped because they're between numbers. It looks like a face. So those are trapped. So how many figures are there? 4. Right? Now, the next one, eggs. You can count eggs, right? So when I say there's 3 eggs, how much uncertainty is there in 3 eggs? None.
And the first one is that all non-zero digits are significant.
Yeah.
Don't you know all non-zero?
Well, it's just not 0. So everything, all the digits are significant except 0. Yeah, yeah. So yeah, so if it's 1 through 9, it's you just say like that's a significant digit, right? If it's a 0, then you have these rules. So that's why these rules break down the way they do. These are everything but 0. And 0, there's all these rules about just zeros, okay? Dealing with 0. So there's no uncertainty in 3 eggs, assuming that you looked in a basket and counted 3 eggs. Reality, there is. I don't know how many of you have ever had chickens and tried to find their eggs? Okay, sorry. They're hard to find because they don't want you to take their eggs. They're the best eggs, though, I will just say. So if you have 3 eggs, okay, 3 eggs is an exact oh sorry, let me put the number here. This is 4. 3 eggs is exact. I'm going to spell it like this. 3 eggs is exact. That's not how you spell exact. Okay? You can count it. The unit is implying that you can count that. Okay? And so the number of significant figures is, I don't care. We would say unlimited because it's an exact number. There is no error in it. Okay? Remember, sig figs is all about how much error there is in a number.
So you write unlimited instead of exact?
No, you can write that. I know you were here. You can write unlimited. They'll usually tell you, like in a problem, if it's an exact number, write exact or something. But if it's on mastering chemistry, don't write it like that because they will knock you off for that. So, C, and then I'll have you guys do the ones on the right. Okay. So C is all the non-zero digits. So I'm going to underline those. Leading zeros, those are the ones on the left side, the way we write numbers, on the left side of the number. Those are not significant. And trailing zeros are only significant if, if there is a decimal, it's significant. Okay? So now I have a decimal. These are the trailing zeros. These are not the trailing zeros. These are still to the left of the number. The things that are not zero, okay? So to the left of the number, those are just all the leading zeros. So there's 2 more over here. So it's a total of 5. Okay. So what I did, just as you learn this stuff, what's really helpful to do is as you apply the rules to the number, mark the numbers differently so you're thinking about what all the rules are. Eventually, you just don't even think about it. You just look at the number and say, well, that's 4, 5, 6. Okay. So far, so good? Because you're the one who asked about sig figs. So I'm going to do the calculations next.
Okay.
Hopefully, I'll do them next. Meteorite hits.
The homework helped yesterday with the sig fig.
Yeah, I made you think about what all the rules are. Yeah. All right, so do that one on D. Ooh. Advantage of being short and heavy, you don't fall over too often. Just saying. What are the non-zero digits? 6 and 2, right? And then what is this zero? Trapped, right? So I have the 6 and the 2 and the trapped, so that's how many? 3. You don't count this. Okay. Because it only it's representing like placeholders like these. And if this had zeros behind it, okay, those would be significant. You would write those in here if they were significant. Here, they're written because they're significant. If I were to convert this one to scientific notation and try to keep the 5 significant figures, I would have to write on that number it as 4.9300 times 10. I'm going to move it to the right, so it's going to go down to the minus third. Okay. These I had to write. Oh, there's a decimal there. Sorry, I got to get used to drawing big fat decimals. These are trailing, but there's a decimal, so they're significant. If you don't write them, then there are only 3 significant figures. Okay? Any other questions? What about E? Sig figs? 4. And F, people hate this one. 1. If you think about like you're walking, well, it's 50 kilometers, it's 40 kilometers, it's 60 kilometers. At that point, it doesn't matter. When I was in England, it was, well, we walked 5 to 10 miles a day. I'd prefer the 5, not the 10, but whether or not it was 6, 7, or 8, it didn't really matter. At that point, it was all the same. Okay. Let's do the next. Oops, I'm hitting the wrong key. And we're just going to quickly go through these, okay? And I'm not going to write on the board, but A is 6, 1, 2, 3, 4, 5, 6. B is 4, 1, 2, 3, 4. C is 1. These are all leading, right? What's D? 3. E? What? I heard 2. 3. Okay, good. And F? Think about it. Unlimited. You got it. Sorry. All right. Because you can count 25 cars. But when they do like the cars, I was talking about in lecture, when you do like the cars on Herndon, right? That's an estimate. They don't count the double axle trucks, and they don't count all those other things that go across those intersections. And they tell you there's like 1 million cars that go through every day, or 100,000 cars that go through every day on a weekday, or whatever that is, some unreasonably high number. That's an estimate. Okay, but 25 you can count. All right, so now what we're going to do is start doing some rules. So these are multiplication division problems. I don't know why she didn't have 2 multiplications and 2 divisions. But the rules are like this. For multiplication division, square roots and powers all the same rules apply. Keep or mark, so I'm making a note here because it doesn't always say this, the sig figs that are the same number of digits as the number with the fewest sig figs.
What are these rules for? What is the...
This is going to be for what you do when you actually use the numbers. Now, when you use these numbers in calculations, okay? So when you do these numbers in calculations, these are the rules. So we're only dealing with multiplication and division. The way I talk about it in lecture, I talk about relative precision. You just want to make sure the relative precision of your answer is the same as the least precise number in the calculation. So if you have 3 sig figs in the numbers that you're using to calculate, your answer will have 3 sig figs. If you have 5 sig figs in all the numbers you're using to calculate, and one of them has 2, doesn't matter that all the others had 5, you're going to round the answer to 2, okay, or mark the second sig fig. The least precise number, okay, the least precise on a relative precision aspect, the least precise number is the one that makes the difference in the answer, okay? So you're really only looking at one number. Okay, so now, sig figs means then you have to mark sig figs for each number going into the operation. So how many sig figs in 93411? I think she got that from a zip code on a television show or something. Isn't that like a zip code? Yeah. And then 335? 3. So, your answer, without even writing the answer, I know how many sig figs are in the answer. There's 3. be a little bit careful because sometimes mastering chemistry in the follow-up questions, especially they'll ask you things like, how many significant figures are in the answer for the following calculation? And students will often just put the answer in and not actually put like the number 3.
So you would put the smallest phrase there?
Yeah, you'd use the smallest because this one is the smallest because the 3 is the smallest here. You're going to use the three sig figs in the answer. So then I do the calculation. I heard clicking on a calculator. Wendy, was that you clicking on your calculator? So what is that answer? Without the 3, just give me 5 digits or so.
I just wrote 312.92.
316.92?
No, 316.92.
And there's a decimal there. 3 sig figs would be this one here. So you round to that place. So that comes out to be 3, 1, 3. Did I get the other numbers right?
Yeah, I wrote 3.13.
So Wendy said she wrote 3.13. To the 2? Yeah.
You could write
Yeah, either one's fine. Unless it says in scientific notation, then you have to do it scientific. But if it doesn't, you can do either. And again, mastering chemistry will recognize both unless it's asking for one or the other. How many sig figs? So, how many sig figs in the number 8? Sorry, this one. The number 847.89. 5. How many in that number? 6. Your answer is going to have 5. So that's what I'm going to mark it at, and then I will round it. Okay. Now, if this is not the final calculation, you mark it, and you don't round. You just keep going on with the calculation. Okay. Is this stuff helpful to you guys? Good. If my kids' games end up being in the evenings on Saturdays, I will try to come in on those Saturdays. Okay. I don't know all the game schedules yet, but I have 2 or 3 games every Saturday that I coach, maybe 5. Because my kids are part of teams that have other teams, and so it wasn't unusual for me for a stretch to go to 6 football games a week. And then people ask me, well, do you like to watch pro football? I'm like, no. I love to watch pro football if I don't have to watch 6 football games a week. So, yeah. But I do love it. So what's the answer?
0, 0, 5, 7. You ran out the numbers?
What'd you say?
Yeah, you have it. 0.0057, 7, 8, 4. You want me to
Yeah, just spew them all in.
7, 8, 4, 9, 4.
Ooh, what a nice calculator, all those digits. How many of those are good? 5. So you go from here, start with the first number, and go 1, 2, 3, 4, 5. Those are all the significant digits.
Sorry, yeah. There's no 7, 8, 4 in between those 2 4s.
It's 0, 0, 5, 7, 7,
Yeah,
8, 4, 9, 4, 1.
84941.
Yeah. Mine just not right.
There, I got rid of them. But those are the first 5 digits. You can, just for convenience sake, mark the last one, because all the ones to the left of it are significant. Okay, so you're going to round that. I would probably advise going to, because it's 3 places now, I'd probably advise going to scientific notation. If you don't, it's not the end of the world. 7, 7, 8, 4 times 10 to the minus third. Good?
So all the time you go to the right, it's negative, it's negative, and all the time you go to the
Yeah. All the time you go to the right, the exponent goes down, and every time you go to the left, the exponent goes up. Yeah, I think that's right. Actually, let me write that down because I think I just said it backwards.
Yeah.
I did say it backwards. This is the reason why I kind of know it's backwards. Because when I do this, I see, oh, it's blue, that's on. I see red and blue. Right? Exponent down. So let's check that. I gotta do something. 3.5 times 10 to the 2. Yeah. So that's actually 350. Well, I moved it like this. 1, and then I had to draw another 0. I moved 2. So yeah, right exponent down. So when you see red, you're doing it right. And then left exponent up. Well, if you say left exponent increases, then you say red leg, which is Hawaiian. So that's just something to help you remember which way the exponent goes. Me, I actually have a hard time remembering the red lay. I just remember which way the numbers go. So that you can use, just remember you're seeing red. Okay, let's do these others. Whoa, I can do the math for that. We're assuming these are measured numbers. So that becomes 3, 0, 0, 6. How many sig figs? There's 4 in the first number. Assuming these are all measured values, then this is 1. So the answer should have 1. I see this all the time. The answer is 3. 3,000. Think of it as the money you're being paid, or the money that you're owed. All right? You would see the problem with that math. It's like this. Without the decimal, it's pretty clear. That's one significant figure. But because the zeros can be very ambiguous and difficult to see, it's typically recommended that you convert that to exponential notation. Okay? What's the next one? Yeah, the answer is going to have how many sig figs? 2. All right, this one's 2 and this one's 3, so the answer should have 2. I do this all the time as I'm doing problems. I think about the number of sig figs as I'm doing the calculations. A lot of times they tell you, do all the calculations and go back to the sig figs. But as I'm going along, because it's so easy, I just keep doing it as I go along. So, what's that going to be? I don't know, 65.3.21 times. What's the number come out to be?
0.0208.
Okay. And you're going to round that to 2 significant figures. So to that place, right? These are your 2 significant figures to match that number. And so you're going to make that, I'll write it right here. Because I chopped the screen off, 0.021. Okay. Or, scientific notation, 2.1 times 10 to the minus 2. Okay. Okay. Maybe that's why I don't do this. My elbow is killing me. Next. Oh yeah. Scroll down. I'm gonna skip these. You guys can do these. Now we're gonna do these. I need to zoom it just a little bit because the screen's chopped off. So hang on just a second. Where's view? Is there a margin width? Which one of those? Whole page width? Ooh, you could do many pages. I want to put 100 pages on there. There we go. All right, so I didn't go far enough down, sorry. There. So now, new set of rules, addition and subtraction, okay? New set of rules. Remember, these multiplication and division rules are about relative precision. How many places is a good number good to? That's why, yeah, these are about relative precision. How many places is a number good to? 1 place, 2 place, 3 place. That's actually what you're doing. Your number that you get an answer for can't have more places in it than the numbers you start with, okay? Addition and subtraction, which are really the same thing, like adding the opposite is subtracting, right? You remember that? My crazy math friends tell me things like that. I just thought it was subtracting. So, are about absolute precision. And then instead of looking at how many places we have, rather like 1, 2, or 3, we actually look at the place, how big the place is. Okay, so the answer is determined by the last known place. So I'll show you what that means, but it's the last known place is where you actually know all the digits in that place for all the numbers. So if I know all the digits in the hundredths place but not in the thousands place, then I round to the hundredths place. If I know all the digits in the ones place, but then one of the numbers I know it in the hundredths place, I can only round it to the hundredths place. The last digit where I know all the values in that place, okay? So, practically speaking, it lines up like this. 9.5 minus 2.26 plus 3.452. When I was younger, I would have just done that in my head. Actually, a lie. When I was younger, I would have wished I could have done it in my head. Now that I'm older, I just think I knew how to do it in my head. Right? The older I get, the greater I was. So, the last place, I know all the digits. You notice how I lined them up by their decimals? Because I lined them up by their decimals because it's the last place that I know. So I have to know where the decimal is in all the numbers, and I'll just draw a line right there. So you notice I'm determining sig figs actually before I determine the answer. You don't have to do it that way, but you can do it that way. So if I add all those numbers together with a calculator, or add and subtract those numbers together, what do you get?
So you're just gonna add it from the line this way?
No, I'm going to add it all up, then I'm going to round it. Okay, so what's the number? 10.92?
Not 8.
That should be. Yeah, that might be 2. Yeah, it's 9. Yeah, I'm sorry, you're right. Because you're subtracted. I was looking at it, it can't be a 9, but it is a 9. So, because the 6 was negative, not the 5. My bad. So I'm going to round this to the 10th place, because that's the last place I know all the digits. You notice I didn't say, well, how many sig figs are in this? I didn't do all that counting sig figs in the numbers, because the rule is different for determining precision when you're adding and subtracting. And so now I have 10.7. Okay? The bathroom's open?
Yeah.
I sometimes forget on weekends, sometimes we'll lock everything. Because homeless people have figured out if you grab the doors on the ends and you just wiggle it like crazy, it'll pop open. Oh, I didn't tell you guys that, did I? Just did. Sorry.
You know how in basic math they teach you the PINDALs, like the order? Like
Yeah.
adding to subtracting? So we're subtracting and then adding, and usually we're taught to add and then subtract. Does it matter?
No, no.
You just go by the sequence of what
Yeah,
they have?
yeah. But if you have multiplication, first you do your additions, your subtractions, then you do your multiplications and divisions. You have to keep the orders of operations still. Yeah. All right. Let's do the next one. I should have brought my condenser mic. That would have been fun. 151. Then 4.16 and 0.0220. Ooh, you know what? Whoa, what happened? It just all erased. That is weird. Okay. It just glitched on me. 151. 4.16 minus, oh, I know what I did. Darn it. 0.0220. I was going to say this answer up here was wrong because it should have units with it. It should have meters with it. That was a bad teacher moment. So I'm adding, subtracting. What place do I know all the decimals to, or the digits to? To the ones place. So I'm going to draw a line here. Now you're going to say, well, that's a 0. Yeah, but I know that's a 0 on the left. I'm just adding a 0 to it. So you add all that up. What do you get?
155.138.
15.
5.138.
Like that. So I'm going to round that. 155 grams. Okay? So this is what I want you to do. I don't want you to actually do the calculation. I want you to set those next two up and tell me what place you're going to keep the answer to. And actually, you can do it without setting it up. You can just look. Okay? Let me do this next one for you. This one that's up here, I guess that would be, if that was A and B I just did, that would be C. Okay, so let's call this one C and we'll be friends. Right. 1. This goes to the hundredths place, tenths place, ones place. Answers rounded to the ones place. Okay, that's how you do that. It's the largest of the least significant digits. Remember I talked about the LSD in class? Least significant digit. I know. Bad. I went to Santa Cruz. What do you expect? You're lucky I'm not wearing my tie-dye. Actually, I have a tie-dye lab coat. My wife has a beautiful tie-dye lab coat. I gave it to her. because we're hippies. All right. No, we're not really. How many? So this is going to be to the ones place. Okay, I'm just going to write that there, because I think you guys can do the math. And then the next one, what place is it going to be rounded to? Tens place, right? You can see that like this. That's the hundredths, right? Tenths, hundredths, hundredths. So that's the largest of the least significant digits. So that's going to be to the tenths. So you're going to be rounded to that place there. Okay? Let's do the same thing with these others. And sorry, it's being really slow. We're just going to determine the place where the number should be rounded to. Oh yeah, reformatted, great. Determine the place where they should be rounded to. The one on the top left over here, you're going to round it to what place? Tenths, because that's the tenths. What place are you going to round this one to? Tenths, because that's in the tenths. Everything else is more well known in terms of absolutes. And then this one here is going to be in the hundredths, and this one is going to be thousands. Okay? So that's what you do with individual operations. Now when you combine operations, you still have to follow orders of operation, and you track significant figures. So we're going to do a couple of those. And that's going to be here. All right. So, I don't need a laser pointer when I do this. So 56.1 minus 51.1 becomes 5.1. And so I'm going to take 5.1 and divide it by 6.58. Now, how many sig figs do I have in the 5.1? Well, what you do is you look up here, right? And this is a subtraction. So I get to keep that to the tenths place. So my calculator said it was 5.1000000. Actually, I didn't use a calculator. I'm just pretending you did. Okay. So then I know that I can keep 2 sig figs on this, so I mark that. The bottom number has how many sig figs? 3. I didn't have to do anything for that one because it was just given to me. So my answer, I'm dividing the top number by the bottom number. I use the addition, multiplication, the multiplication, division, roots, and powers rules, the top one over there, and do relative precision. How many sig figs will be in my answer? 2. So somebody do that calculation for me, because because this number. Question was, how do I get 2 again? This has got 2, and this one's got 3. I'm using the multiplication division rule, which is the least number of significant figures. Since I have 2 significant figures in this number, I can't have more than that in my answer. It has to be. Yeah, use the least. And with addition and subtraction, using places.
So when there's a multiplication like mixed in with like an addition and subtraction, use the multiplication rule.
Yeah, for the multiplication part. But you do orders of operation, so everything by orders of operation. When you do an addition and subtraction first, you track the significant figures, but you don't round. And then you do if it's a multiplication or division next, you do that, and you track the number of places, the least precise number. Okay, so what's that number come out to?
Big number 775.
775. And then, that's, and where's the decimal?
It's in front of the first one.
Oh, 0 point. Okay. So I'm going to round this to 2 sig figs, so this becomes 0.78. All right, let's do the next one. here. We'll call that, we'll go vertically A, B, like that. So now what I'm going to just take 8.12 and add 7.53. And I'm just going to do this because I'm too lazy to get the calculator out. 15.65. Three times 3.710. Now, what place do I know this addition to? Hundreds. So there's actually, even though there's 3 sig figs in each one of these, it comes out to be 4 in total. That's the last known place in the 5 there. So I know this one to 4, and I'll mark that in my calculation. This one I know to 4 because it's given to 4. Okay. Multiply that out, and that one I will just rely on somebody's fancy calculator. There's 4 in here. How many sig figs will be in my answer? 4. So what'd you get?
58.06.
It's a 58.1?
0.06.
0.06, and was there something else after that?
Oh yeah. 1.5.
1.5, good. So that's where I'm rounding it to, so I get 58.06.
So for adding, you use the absolute rule.
Yeah, yeah, yeah. Yeah, good. How many of you have never seen this before? Okay. Did you all go to school together? I'm hoping it's just one school. Have you had the math prerequisite? Right, you took, where'd you take the math prereq? Here?
I just had stats.
Really? But you had math in high school.
Yeah.
Yeah, right?
Yeah.
Because here we teach it in the prerequisite math course. I was just actually talking to the lady who does all that sort of math stuff, and she's developing a new class, or she's revamping an old class. It's actually the very introductory algebra class, the one you take even before the prerequisite, so people can learn this, because apparently it's not being taught anymore. So, yeah. So.
I didn't really have to do that.
Yeah, well, I didn't either. Like I don't know. I learned things in high school I'm not going to talk about. All right, so now let's do the next one. That's going to be here. Okay. Again, we'll call that C, so we're going to do C. What place will I know that addition to? Tenths, good. So I will just write it down, 5, 1.1, I'm going to add those. I'm going to get 2, I will get 7, I'll get 1, 0.7, 2, so I know that to there, and then I'm going to divide that whole thing by 6.58. Again, I'm following orders of operation. I know the 6.58 to 3 places because it was just given to me that way. Okay. I didn't have to track it, but I always mark it so I remember. So 10.72 divided by 6.58. $16.29. And I'll assume that that's right. And if I don't get any objections, that is the number. What power you wield. Oh, interesting. All this kind of stuff screws with people because I didn't put parentheses. It's amazing. This thing's really working today.
But what if it's 10.72, not 107.3? Yes, 107.2.
Ooh, yes, it's 107.2. So then it's 162.9. It's that way because I make mistakes. There. You have a question? What's up? Really? No, but it's got to be. Because it's 50 and 50, it's got to be over 100.
No, yeah, I got 107.2, and when I divided by 6.58.
Oh, yeah. I got it. It's still 16.29 because I'm dividing. Or I could do this. If I was really clever, I would edit it and it would be like I never made a mistake.
And on there,
You will find mistakes on my YouTube.
when did you transfer the six figures? How many six figures does it have? Because on A, you said 2. And on this one,
Oh yeah, I did the wrong. Look at that. I got all in a hurry. Shouldn't have sat down. What's wrong with my answer? I said, well, that's the answer. Yeah, it's supposed to be 3. Come on, guys, speak up. I sometimes make mistakes on purpose. I didn't do that this time. 16.3. This is not like a lecture where I've practiced, right? I'm just working problems. I will make mistakes. In lecture, I make fewer.
For the left one, top, is there a reason why it's 5.1 versus 5.0?
It's supposed to be 5.0.
See? It's supposed to be 5.0.
For the bathrooms or
Should be. You want, you guys know that,
It's open.
yeah? You want to go to that one though?
Yeah.
Yeah, go that way for sure. The other clever trick is if you ever get stuck outside the building, a lot of times the elevators are on. Because I do these Saturday things a lot. And then police always come by.
so just to check, that would be 3 significant figures, right? Because it's the least 6.5.
The one C, what we're calling C?
Yes.
Yeah.
That would be 3 significant figures.
Yeah. Because of the 6.58.
Yeah.
Yeah.
Because
Because
the top one has 4, right? 10.52 has 4. And 6.58 is 3, so it's
Yeah.
below 3.
it should be 3, so you round it to that place so you get in the
Oh,
place.
okay.
Okay.
Are you gonna put these on YouTube like by today?
When we leave,
Okay.
I will just start streaming this one up. So in fact, I think I am just about done with this segment. I will stream it up to my YouTube. We'll take a short break. And then I'll do the next segment. So these are all more practice of the same things. It just get a little bit more complicated. The tricky one, I'll show you a couple of these tricky ones, like this one here. That one's tricky. The reason that one is tricky, it's because one is in scientific notation and one is not. So you have to convert them to have the same exponential format. So let me show you really quickly on this one. So we're going to be right here working on this problem. It says 2.023 minus 1.8 times 10 to the minus third. So you're going to have to write 2.023 minus, and then 1.8 times 10 to the minus third, right? Which way do I move this decimal? To the left, right? I'm going to have to move it 3 places. So it's going to go 1, 2, 3. That means there'll be zeros in front of it. Again, that looks like a face. I love doing that. So it's going to be 0.0018. Okay. Now, when you do the subtraction, you'll keep it all 4 significant digits of that first number. So that's going to be 2.0212. Did I do that right? Let me check my math. Right? Got decimals there. That's my last, the 1 is my last significant digit. And now I have to divide it. By 1.05 times 10 to the minus 4. Or 10 to the 4, sorry. And what do you get? 0.92 times 10 to the negative 6, 4? Yeah, that seems about right. Well, you're dividing by 10 to the minus 10 to the 4, so it's going to be to the negative 4 in the answer. Now, if you didn't get that in your calculator, you're not entering it correctly. And that's something we need to fix.
I answered, you said negative first, but this is positive 4. That's what I'm saying.
Oh, I said, oh yeah, but I wrote positive. I see that? I fixed myself.
Oh, okay.
If you have your phone, you can't do that, man. You can't do that, man.
Turn it sideways.
So I have to
Oh yeah. When you flip your phone calculator, so you can't get a calculator, but when you flip your phone calculator sideways, it should go to a scientific format, and there's an E for exponential notation. Or you can use my favorite app. Hang on. Oh, I don't want to get out of this area though. Darn it. I'll show you my favorite app. You have to buy this app, but it is worth every single penny you pay for it. Did I show you? I think I showed one of the classes this website, Wolfram Alpha. Yeah, Wolfram Alpha is an app you get on iPad, Android. It's like a $3 app. On the website, it's like a monthly subscription. It's crazy. I wouldn't do that, but I would get the app. And then what you can actually do is you can put in a derivation that you need, like an integral of a certain equation, and it will show you step by step how to do it. You can also ask it, like, what's the average height of boys between 9 and 10, and it will show you a graph of the average height of boys between 9 and 10. It's crazy. It just has all kinds of data that it's connected to.
How much does it cost to get that?
The web interface is free. So like if you have simple equations, like where you need to solve for 1 or 2 variables or 3 variables, it'll do that for you for free. All right, and that's not necessarily simple. I'm just saying they're calling that.
So now, let's say we don't get a problem, we type it in there and give you an answer.
If you can set it up. You have to set up the equation and it'll give you the answer. So. But if you want to do simple math things, like, let's do this real quick. 1.25 times 10. You can use the same calculator notation that you use for your calculator, to the minus 3 divided by 24.55, and then you hit enter. It'll actually show you what the answer is. It'll even graph it for you, and I don't think you need that many digits, but you know, just in case you are interested what it was at the 100th place. It will give you that, but if you want more digits, that you have to pay. Okay. Yeah, this is like my favorite app. I showed my students for the summer class in Chem 1B how to use the app because they have to solve lots of quadratic equations. If you have to solve a quadratic equation, this is the fastest way. All right. Unfortunately, I can't let them use it on tests because it's also the fastest way to cheat because you can just go on the internet and look for stuff. But if I could let people use this app on their phone on exams, I'd be like, that'd be so awesome. But I can't. It'll even handle some unit conversions. So they can put the units in and convert it.
Put the problem and give you that?
Yeah, the math problem will give you the answer. But in the app, it's just on your phone. You just use it like a calculator. You just type it in. Okay, so anyways, that's just a side note. It's better to have a regular calculator. If you don't have access to a cheap calculator, scientific calculator, let me know and I can probably find one. I'll just walk through the classroom every day and I will find one eventually. So. I've got a bunch of them actually. The department bought a bunch, and so I have a bunch. So if you really need a calculator, just let me know. Then we buy them and put them in the, they're not free. They don't just like appear from nowhere. But we buy them and we put them in a box. All right, so that's that. So let's go ahead and I'm going to stop this.